Algebra 1 students, these are your 9.3 notes. On a day like today, when technology is all going wrong, it feels like we need to break up and just move on with our lives. Go old school with what we do. But we're better than that, and we know this works. So we're resilient, we make this relationship happen. So let's do some solving quadratic equations. Bye, Taylor. Alright, folks, we've been looking at ways we can break down quadratics by doing things like factoring and even some graphing. But today we're going to look at two methods that are available to us to solve quadratics: graphing and using square roots. Now, I'm going to throw four terms at you. They're all underlined here. They're in purple on my page, but solutions, roots, zeros, and x-intercepts. These are all closely related terms. We say that equations have solutions, or sometimes you see them called roots, where graphs would have zeros or x-intercepts. Now, if you look down here, we see three different scenarios. Sometimes quadratics have two solutions, or two x-intercepts, or roots or zeros, whichever way you want to think of them. And that would be the case where if the vertex is below the x-axis, then it opens upward, or if the vertex is above and it opens down, like you see here. So we have two places on each of these graphs where we intercept the x-axis. Those are our zeros, or our solutions. The next scenario is that we have only one solution. There's a word I'm going to throw out here. If they're tangent to, that means they touch but they don't cross. If the curve is tangent to the axis, we have exactly one solution. And sometimes we get no real solutions, like this scenario here where they never cross the x-axis. You'll look at in more depth at that in Algebra 2. We have something called imaginary solutions, and you can only imagine how fun they might be. Alright, we're going to take a look at how we could solve. First, we'll solve by graphing. Now, we're going to use Desmos here. So the first one is x squared minus 81 equals 0. If you're watching on a calculator, go ahead and go to Desmos on your own. So we're going to do x squared minus 81. Alright, now from the window I have here, I can't really see what's happening, so I'm going to zoom out just a little bit by pressing the minus. When we use the tablet, this is an easier thing to do. We can do the old pinch and zoom. But folks, what we're looking for are these points right here. Negative 9, 0 and 9, 0. Those are the key to what we're doing. So I'm just going to go back over here. I know that the solutions are x would equal 9 or negative 9. And again, that comes from having zeros at plus or minus 9 and 0. Continuing on to number 2, we start with the equation x squared plus 12 equals 0. I kind of neglected this a little bit when I talked about the first one, but what we want to graph is y equals x squared plus 12. Now, Desmos is smart enough that if we just put x squared plus 12 in there, it will go ahead and assume you mean y equals. And I've got that one graphed already right here. You can see it. Now, this is an interesting one because you'll notice this graph never crosses the x-axis. Now, we looked at that scenario at the beginning and we said anytime the graph doesn't cross the x-axis, there's no real solution. Alright, so let's look at number 3. We run into something slightly different on number 3, where we have numbers on both sides of the equation. Let's go ahead and simplify just a little bit by subtracting 7 from each side, and we'll have x squared equals 0. Now again, we want to just graph y equals x squared. And I have that graph ready for you as well right here. Now, what I'm going to do is go ahead and click at the point or points, and in this case there's just one point where we intersect the x-axis, and it's actually in this scenario right at the origin. Okay, so a little bit of an interesting graph there, but the only place that it's true is when x is equal to 0. And again, we're not writing our answers as ordered pairs on these problems. We're writing them as x values because our equations just say x equals, or in this case, like number 4, 5x squared minus 80 equals. But there's no y value here, only x values. Now again, let's go in and graph 5x squared minus 80. I've got that one ready for us as well. You can see it here. Note my window adjustment is pretty significant. My x values go from like -10 to about +10, but my y values, I mean, this point right here is somewhere down around like, yeah, there it is, -80. All right, but what we really want are not y-intercepts, but x-intercepts. And you can see there, they're at +4 and -4, so I can go back to my notes, and I know that x would have to equal plus or minus 4. Now, if you'd prefer to write x equals 4 or x equals -4, that's totally fine. Either way, we get the same thing. Does it bother anybody that I've got a green box around blue numbers? Just don't think about it. All right, we have another method we can use, one I like, honestly, and that's solving by square roots. Anytime we have a quadratic in the form ax squared plus or minus c equals 0, we can solve by isolating the x squared term and then take the square root of each side. And just as a little reminder here, if x squared equals c, anytime you take square root of both sides of an equation, you have to do plus or minus. So here we go. We're going to solve by square roots. This is just the algebraic method here. A squared equals 225. So what I know is that a would have to be plus or minus the square root of 225. So a then is plus or minus 15. Piece of cake. I like these problems. All right, so let's look at number 6. I'm going to add 8 to each side so that I can, again, I'm trying to isolate w squared before I get too far here. So 3w squared will equal 0. Divide by 3, and w squared then would be 0. Now this is the scenario where we only have one solution. We saw this graphically, but algebraically we can see it's only one solution because the square root of 0 is 0, and plus or minus 0? Well, there's no such thing as -0 in the world we live in, at least the world most of us live in. All right, let's do two more. Number 7, 4x squared equals 4. First thing, isolate the x squared. So we'll divide both sides by 4. So we'll know that x squared is equal to +1. And then x would equal plus or minus the square root of 1, which is just simply plus or minus 1. Okay. One more, and I've decided I want to add one more. There's a situation we haven't run into that I want to make sure we run into. So 16v squared is equal to 9. We'll divide by 16. And then, again, I need to take the square root of both sides. So v then is plus or minus the square root of 9/16. So finally, v would equal plus or minus 3/4. So on both of the scenarios you see here, on problems 7 and 8, we have two solutions. If I go back, I can look at 5. I had two solutions. On number 6, I don't know if I circled it or not. Let's see. I sure did not. Number 6, I only had one solution of 0, but there's something I have totally neglected, and that's not the way we work here. We're going to go ahead and address that situation as well. Let's say I had -4x squared equals 16. So write this one down, follow with me. This is an important one to consider as well. Divide both sides by -4. So x squared equals -4. So x equals plus or minus the square root of -4. Well, how do you take the square root of a negative number? Well, the honest answer is you can't until you learn about imaginary numbers. And so in this case, we would just simply say no solution. Alright folks, that's the end of the lesson. The background noise today has been brought to you by pre-calculus students who are in here working hard. Much appreciated. So mad props to Eric, Jackie, and Matt. And for you Algebra 1 students, you can strive to be like them someday. But for today, let's learn how to solve square roots. We'll see you tomorrow.